Right, having understood what sequence is, I want us to also go briefly on what we mean by series. Okay, now we said by definition, when the terms of a sequence are added together, the expression obtained is called a series. And we now say that the sum of terms of a finite series can be calculated. That is, if you know the last term of the series, you can find the sum of the terms of that series. Okay, now, like we had a sequence 2, 4, 6, 8, 10, isn't it? And then you now say, okay, by the time you add them together, what you obtain is called a what? A series. So this is a sequence, but when we now add it like what we have here now, instead of 2, 4, 6, 8, 10, you now see that we have 2 plus 4 plus 6 plus 8 plus 10, and these 3 dots means there are so many other members of this very series. So it's an infinite series. So this is called an infinite series. Okay? There's another example here. We have 5 plus 10 plus 15 plus 20 plus 25. Now, the sequence here is 5, 10, 15, 20, 25. That is the sequence. So by introducing addition sign in between them, it becomes a series. Right? Now you see, since this one stopped, there is no dot after it. You see this one, there is a dot, isn't it? You see there is no dot. That means this is the last term of the sequence. And therefore, it becomes a finite series where we add like this. So I can say 5 plus 10, which is 15, plus 15, 30, plus 20, 50, plus 25, 75. So I can add this and get 75 as my final answer, since it is a finite series. Are you with me? Then we have another one here. We have 3 plus 0 plus minus 3 plus minus 6 plus up to plus minus 21. Now, in this case, we know the last term, but we cannot say this is the actual value of the series until we find some other things. That's until we know how many terms are there. Because these 3 dots now means there are some terms, not only 3 of them, there may be more than 3. That means there are some terms in between before you get to minus 21. Okay? So in this case, we can find the sum until we know how many terms. And when we go further, we'll see how to go about all of those things. So this is what we mean by a series. Okay? Now, when we now go to arithmetic progression. Arithmetic progression. Now we said an arithmetic progression, in short, the shortcut for arithmetic progression is AP. So an arithmetic progression is a sequence, don't forget, it's a sequence in which the consecutive terms increase or decrease by adding or subtracting a constant. Very important, all these things that I underline the definition. Now what we're saying is that an AP is a sequence, just we have finished talking about sequence. But in this sequence now, the terms either increase or decrease. So the terms increase by adding a particular number or decreases by subtracting a particular number. And that particular number is what we call the constant. Okay? Now, take for instance, I have 2, 4, 6, 8. You see that this one is increasing, isn't it? And it's increasing by adding what? 2. So when we're thinking about sequence, we say the rule is add 2 each time, right? So here, that 2 that we are adding each time is called the constant. Okay? And this constant, since it's an AP, has a special name, and the name is called common difference. So the constant that increases or decreases a particular sequence is called, sorry, the increase or decrease a particular arithmetic progression is called common difference. And I say the constant is called common difference. It is obtained by subtracting the first term from the second term, or the second term from the third term, or the third term from the fourth term, or the fourth term from the fifth term. So for instance, I have 1, 3, 5, 7, 9. This is a sequence. And of course, this is an increasing sequence, isn't it? And this after 1 we have 3, after 3 we have 5. That means add 2, you get this, add 2, you get this, add 2, you get this. So the common difference D is 3 minus 1, which is 2, Or in fact, I can even say 9 minus 7 is still 2. Okay? So that is how we can get the common difference of any arithmetic progression. Alright, even if the sequence is decreasing, then you still get it the same way. Okay, we say generally an AP is A, that is the first term is A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D. Now, look at it. This is the first term, second term, third term, fourth term, and it continues like that. So you now see that, like in this example that we have, the first term here is 1, isn't it? Now, what is the difference? We got 2. So if I just say 1 plus 2, that is A plus D. Our A is 1, our D is 2. So if I just say 1 plus 2, I will get 3, isn't it? If I come here, I will say A plus 2D. Remember our D is 2, isn't it? So 2 times 2 is 4. So 1 plus 4 will have 5. And then if you continue like that, you get your AP. And we now see the end term of an AP now. The first time is A, the second time is A plus D, third term. And so if you observe what we are having here, A is repeating itself, isn't it? So if I want to find the end term, maybe the 100th term, the term I don't know, isn't it? Then it's going to be A plus. Now if you look at it, this D, 2D, 3D, here is the same thing as 0D. And our n is 1 here, isn't it? So if I have n minus 1, that is 1 minus 1, I'll get 0. Here, my n is 2. If I have 2 minus 1, I'll have 1d. Here, my n is 3. If I have 3 minus 1, I'll have 2d. Here, my n is 4. That's the fourth term. I'll have 4 minus 1. That's 3. That's why we have 3d. So I say, okay, if that's the case, and I don't know what n is, that means it's going to be n minus 1 times the common difference. So, the coefficient of our D, or the common difference, is always 1 less than the number of terms. Now look at it. The number of terms is 4. The coefficient is 3. So 3 is 1 less than 4. The number of terms here is 3. Here the coefficient is 2. 2 is 1 less than 3. So that means if I want to find the 100th term, that is the 100th term, there is going to be A plus 99D. That is 1 less than 100, okay? If I want to find the 50th term, it's going to be A plus 49D, 1 less than 50. So that is it. So with this very formula now, we will now be using it to solve related problems on arithmetic progression. And the n term, that is the n term, which is n with th, equals to A plus n minus 1d, can also be given in terms of un, which is the same thing as A plus n minus 1d, or tn, which is A plus n minus 1d, or even the last term now, which is L, is still n minus 1d. So all these things mean the same thing. Okay? What I want you to take note is that the last term is equivalent to the n term of any AP at all. Okay? So the last term, when the last term is given to you, is equivalent of saying they have given you the what? The n term. And we will now use this to solve related problems. And one thing also is that in handling arithmetic progression, you should always be conversant with how to solve simultaneous equations, because when we go on, you see us solving simultaneous equations in some of the questions we are going to take. Right, we have an example here. The first question is find the 71st and n term of the AP, minus 4, minus 6, minus 8, minus 10. So our given AP is minus 4, minus 6, minus 8, minus 10. And there are so many other terms. Now, the first thing is that we need to know the common difference. Remember that the formula for finding any term, the n term, is A plus n minus 1d. So for us to find the 71st term, we need to know what A is, we need to know what n is, and we need to know what d is. But in this case now, our A is the first term, which is minus 4. our D, we said is the common difference. And the same thing as the second term, minus 6, minus the first term, minus 4. And this will give us minus 6 plus 4. Right? Because minus times minus is plus. And then minus 6 plus 4 is minus 2. Or you can use minus 10 minus 8. That's minus 10 minus 8. Please don't make this mistake and say minus 10 minus 6. No. There shouldn't be a time in between what you are using. So that this will be minus 10 plus 8 and still minus 2 we have, isn't it? Then our n, since we want to find the 71st term, so for 71st term, our n is going to be what? 71. Okay? So that is what we need to know. So that we now say the 71st term now will be, instead of n we have 71st, isn't it? So we are going to have a, that is minus 4, we got a to be minus 4, plus, open bracket, 71 minus 1 times minus 2. Then we simplify this, and that will be minus 4 plus 71 minus 1 is going to give us what? 70. So you have 70 times minus 2. And 70 times minus 2, this is positive 70. Minus plus times minus is minus. 70 times 2 is 140. So minus 4 minus 140 will give us minus 144. So this is the what? The 71st term. Then the B part now. The B part, we have to find just the n term. And the n term is a plus n minus 1d. We need only a and d. That is, our answer is going to be in terms of the n, since we don't know what n is. So we have our a is minus 4 plus n minus 1, our d is minus 2. So you now see, we will use this minus 2 to open up this bracket. Okay, and that will be minus 4. Minus 2 times n will give us minus 2n. Minus 2 times minus 1 will give us plus 2. Please take note. What we have here is equivalent of me writing it like this: minus 4 plus minus 2 into n minus 2. Sorry, minus 1. That is, if I just bring this one before here, so that we'll just use it to open this bracket, and that will give us minus 4. Minus this times will give us minus 2. This times will give us plus, sorry, 2n. Then this times will give us plus 2, which is essentially what we have here. I'm doing this because some of you are already used to opening bracket with a term before it here. So it can still be after it and you use it. That is minus 2 on this, we got this, minus 2 on this, we got this. So we collect like terms, minus 4 and plus 2 are like terms, then minus 2n. Minus 4 plus 2 give us minus 2, minus 2n. And that is the what? The n term of this very sequence. Okay, so you remember the first thing we did on finding the n term of a sequence. You just pick it like this and you work it out the way we did in the tabular form. You get minus 2, minus 2n, and that will be the correct answer. Okay, we now have another question here, another simple question. The question reads: the 11th term of an AP is minus 31, and the 21st term is minus 71. Find the first and 15 terms. So let's see what this one will give us. Let's interpret the question bit by bit. The first thing is what? What is the formula for n term of an AP? Let me use un here. Remember, I've given you all that you can use. N minus 1d. So in this case, I say the 11th term is minus 31. And the 21st term is minus 71. So we don't know a, we don't know n, we don't know anything yet. So let's substitute what we have and see what it will give us. So the 11th term, that's my 11th term, or let me say U11, is something as a plus. Now that means our n is what? 11 in this case. So we have 11 minus 1, but we don't know d. But the question says the 11th term is what? Minus 31. So I will say equals to minus 31. And looking at what we have here, we have a plus 11 minus 1 is what? 10. So I have 10 times d is 10d equals to minus 31. We call this one equation 1. Because we have 2 unknowns. So let's check the second part. It says, and the 21st term is minus 71. That is u21 is equals to a plus 21 minus 1d. And the set is what? Minus 71. Okay, so we now have a plus 21 minus 1 is 20. Then 20 times d is what? 20d. And we have equals to minus 71. You can call this equation 2. And now look at equation 1 and 2. They are simple and straightforward quadratic equations, isn't it? So we solve simultaneously. So we now say solve equation 1 and 2 simultaneously. Now let's bring down our equation 1. It's a plus 10d equals to minus 31. Equation 2 is a plus 20d equals to minus 71. Now you can use any of the methods of solving simultaneous equations and get it. But here I can quickly subtract. A minus a is 0. 10d minus 20d give us minus 10d. Remember, it's just 10 minus 20. And 10 minus 20 is what? Minus 10. And then we have equals to minus 31 minus 71. Now, this is minus 31 minus minus 71. That will be minus 31 plus 71. And to do this with ease, you can just say 71 minus 31. And this is 0, this is 4. So we have this to be what? 40. So we want to get d, we have to divide both sides by what? The coefficient of d, which is minus 10. So I'll divide this by minus 10, divide this by minus 10. This will cancel out. And then d will be 40 divided by minus 10, and that will give us minus 4. That's we've gotten the what? The common difference. Now, remember our target is to get the first term and the 15th term. And before we can get the first term and the 15th terms, we must know the common difference and the first term. So thank God we've gotten our common difference. So let's see how we can get our A. Now, just like the way we solve normal simultaneous equations, use any of the two equations and then we substitute our D. So using equation 1, which is A plus 10D equals to minus 31. Our D is minus 4. So we have A plus 10 times minus 4 equals to minus 31. And that will give us A minus 40, that is 10 times minus 4, is equals to minus 31. Okay, let's use the space here. Now, here we collect like terms, isn't it? So that we will have A is equals to minus 31 plus 40. And minus 31 plus 40 is the same thing as 40 minus 31. Okay? And 40 minus 31, you borrow 1, you bring A, it becomes 10. 10 minus 1 is 9. This is 3 minus 3 is 0. So our answer is going to be what? Positive 9. That's the first term. So with this, we have gotten the first part of the equation is our A. So let's say therefore, the first term is 9. Then the 15th term, let me use U15, will be A plus 15 minus 1D. That is our N is 15. And that will be A plus 14D. We already have A to be minus 4, sorry, A to be 9. So this will give us 9 plus 14. And then D minus 4. Right, so we now have to open this bracket. We have 9. Then 14 times minus 4 will give us minus 56. Then we now say 9 minus 56 will have minus 47. And that is our what? 15th term. And with this, we finish answering this very question. And then we'll pick some more examples and then you see how to go about solving related problems. Right, I hope you're learning something here. Let's take our next question. The question reads, the fifth term of an AP is 40 and the 7th term is 28 more than the 3rd term. Find the 10th term. So I need to take note of what this question is saying. We have the 5th term to be 40, and the 5th term is, that is T5 is A plus 40. Remember, we're using Tn equals to A plus n minus 1D, okay? So I have 5 minus 1, which is 40, and it's what? 40. Let's call this equation 1. That's from the first sentence. Then the next thing is, and the 7th term is 28 more than the 3rd term. Please don't confuse yourself. The 7th term is 28 more than the 3rd term, not that the 7th term is 28. What that means that the 7th term is going to be the 3rd term plus 28. Okay? Or you can say the 7th term minus the 3rd term will give you 28. That's what this question is talking about. So any of these two approaches you use, you get it right. So let's use the second one. That is the 7th term. That is the 7th term minus the 3rd term is what? 28. Now let me just bring you close. If I have two numbers, 10 and 16, okay? By how much is 16? Or by what is 16 more than 10? Of course, it's going to be what? 6. How do you get 6? 16 minus 10. Okay? That is why I say, okay, since the 7th term is 28 more than 3rd term, that means the 7th term minus the 3rd term will give us what? 28. So with this, you find it very easy going with this very easy. So let's go back to what we have. So what is our 7th term? Remember, using this very formula, the 7th term is going to be A plus 6D minus 3rd term A plus 2D is equals to what? 28. Okay, then let's open this bracket and see what we have. So we have A plus 6D minus A minus times plus is minus 2D equals to what? 28. So collect like terms. A minus A is 0. 6D minus 2D will give us what? 4D. And then we have 4D equals to 28. So we divide both sides by 4. Divide by 4. Our D will be what? 7. So you see, this question has helped us. I thought we would come and arrive at two simultaneous questions like in the previous example. But by simplifying this, A was eliminated, so we are left with our final answer, which is D. So we just go back to the first equation here and then find A. Then we can now get our 10th term. So going back to equation 1, which is A plus 4D equals to 40. Our D is 7. So we have A plus 4 times 7 equals to what now? 40. And then 4 times 7 is 28. So we have A plus 28 is equals to 40. You collect like terms, A will be 40 minus 28. And then 40 minus 28 will give you 12. Okay? So that is our first term. Then you now go back to the actual question now. The question was, you should find the 10th term. So the 10th term now, that is T10, is A plus 9D. And we got A to be 12. So I have 12 plus 9 times D, 7 times 7. So what is 12? 9 times 7 will give us what? 63. So we have 12 plus 63, we have 75. And that is our 10th term. Okay? So that is that for this very question. And I hope you are learning something here. Let's take the next example we have here. And this example is also a bit different from what we have because it involves ratio. So the question reads, the first term of an AP is minus 8. That is our A now. Our A is minus 8. The ratio of the 7th term to the 9th term is 5:8. That is 7th term, let me use T7 ratio T9 is equals to 5:8. Please, I hope you already know what ratio means. Okay? Ratio is another way of writing what? Fraction. So let's go on. Seventh term. Seventh term is a plus 6d. Ninth term is a plus 8d. That means that our a is minus 8, remember? So that means this one is minus 8 plus 6d, and this one is minus 8 plus 8d. So seventh term ratio, 9 times 5 ratio 8. That is t7 all over t9 is the same thing as 5 over 8. And that implies that minus 8 plus 6d as our seventh term divided by the ninth term minus 8 plus 8d is equals to 5 all over 9. So if you have something like this, it's very simple and straightforward. You can quickly cross multiply and then find our d, since we are asked to find the common difference of the progression. So when you cross this, we have 8 into minus 8 plus 6d is equals to 5 into minus 8 plus 8d. So 8 times minus 8 will give us minus 64. 8 times 6 will give us 48. Is equals to 48d is equals to minus 40 plus 40d. So you collect items. 48d, bring this one back here, minus 40d is equals to minus 40 minus 64, sorry, plus 64. Taking this one back here becomes positive. So 48 minus 40 will give us 8d. Minus 40 plus 64 is same thing as 64 minus 40. So we have 4 here. We have 2. So we have 24. So we now divide both sides by 8. Divide both sides by 8. This will go. D will be 24 divided by 8, which is 3. And that is the common difference of this progression. So we pick one more example and then move to the next thing. Okay, let's take our next example. That's number 5. The question is, the first term of an arithmetic progression is 3. That is, our a is 3. And the fifth term is 9. That is, t5 is 9. Find the number of terms in the progression if the last term is 81. That is, our n is 81. Now, t5 is a plus 4d. Don't forget. And L is a plus n minus 1d. When we say the last term of an AP is the same thing as the nth term. So let's use what we have and then see what how we can get the number of terms, that is n. So here, since we are given the fifth term, that is a plus 4d is given to us as 9. Then a is also given as what? 3. So I'll have 3 is equals to 4d. Sorry, 3 plus 4d is equals to 9. You collect right terms here. 4d is equals to 9 minus 3. So that 4d is equals to 6. So we have to divide both sides by what? 4. So that we have 4 here. 4 will go with 4. D will be 6 all over 4. And 2 here is 3. 2 here is 2. That's our D. But the question is to find n, that's the number of terms, not d. So let's go back. We have the L, that is our last term, is given to us as 81. So now say, since L is 81, that means that a plus n minus 1d is equals to what? 81. So our a is 3, as given in the question, plus n is what we are looking for, and then we got d to be 3 all over 2. So that equals to what? 81. Then we'll now simplify this. So I have 3 plus this 3, the whole of this 3 over 2. We'll multiply this to give us 3n all over 2. And the whole of it also multiply this to give us 3 all over 2 equals to what? 81. No. So to make it simpler, we can clear up the fraction by multiplying 2 by LCM, which is 2. So if we multiply this by 2, we'll have 6. Multiply this by 2, we have 3n. Multiply this by 2, we have only 3. And of course, to multiply this one by 2, we have 162. Then we now collect like terms. 3n is equals to 162. Bring this one here, it becomes plus 3. This one will be minus 6. So we have 3n is equals to 162 plus 3 minus 6. We have 159. So divide both sides by what now? 3. So we divide by 3. So our n is equals to what? 53 as our number of terms. So there are 53 terms in the word progression, even that the last term is 81. So that is that for this very part. And then I would like you to solve so many other questions similar to this. In our next lesson now, we will look at how to find some of terms in an AP. After that, I will now give you some exercises to do.